Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, August 18th. Tonight, we will do our normal presentation of projects and then open the floor up for discussions or questions. A little bit of housekeeping. Robo Columbus 2026 is coming up. About 3 months left before the competition. Usually at our Saturday, November meeting. Monthly meeting. So get your bots ready and get them going. Saturday, we also have our monthly meeting. I will let Paul give a little bit of heads up on what's going to be happening Saturday. Go ahead, Paul.
Thank you. Okay. So we did have a tech talk scheduled on the Arduino Q, which I thought would be really interesting, a tool set aimed at Arduino Q, but our speaker was not well and had to reschedule to October. So Mark and I cooked up something that is different than we've done before, and I think it'll be a lot of fun for the Saturday meeting, at the Saturday DPIG meeting, which will be at the Dallas Makerspace as always. So we're calling it the Hackerbot Challenge, and so we're not the idea is to have fun hacking a bot with like no preparation, so it's like time constrained hacking. Be as inventive as you or creative as you want. So we'll have whoever's there will form 4 teams, and who will be given a goal that we're not announcing in advance, and but the teams will need to work together on accomplishing the challenge that they'll be given at the time, and then so we'll probably start around I think 10:30, because usually we start the meeting around 10:15, and we'll have like 15 minutes of like, okay, here's the overall concept, structure, what you're being given, and then we'll work through till pizza at noon, and then we'll decide how far along everyone is, if we want to continue over lunch, or if we want to declare that testing will begin after pizza, and the testing will be a death-defying contest. So it'll be fun, and so we'll probably there'll definitely be soldering involved. So people who attend, someone in each of the 4 teams probably ought to have a soldering iron and usual hand tools for electronics and light mechanical assembly. But we'll have options for hacking with cardboard, hot glue, and maybe tape, whatever. There'll also be extra points for involvement of a microcontroller, although that'll be optional, and the basic challenge will be able to be accomplished without a microcontroller, but there'll be extra points available if there is a microcontroller in that operates in certain ways, and Mark D is going to bring microcontrollers. I'm going to bring the rest of the hardware that will be needed, the parts, the Mark and I will bring the rest of parts and materials that you might find useful. So it will be possible to complete the challenge at a basic level with nothing more than what's provided. But there'll be a ratcheted point system that if you get creative, inventive, then you can do better and get more points. Prizes will be bragging rights, basically, a certificate and bragging rights. And let's see, we're going to live stream it. for and you know the first considerable while, 45 minutes to an hour, will be maybe a bit boring for watchers, but then I think it'll get interesting. So, Mark, do you want to add anything to that description of the Saturday event?
Nope, I think you got it.
Okay. Are there any questions that we don't want to answer?
Is it expected to move?
Yes.
Yes.
In what way?
Find
That
out.
would be probably giving away too much.
Yeah.
Well, to say it should move like most of the robots that this club engages with is probably enough.
So the words death-defying were mentioned. Is that for the participants or the robots?
Hopefully not
The email specified robot, so
Yeah.
Yes,
Okay.
yes. It's the
Clarify
robots that may die.
however, with
Is
this,
there
with
a,
this group, you never know.
Is there a storytelling component, or is it simply the robot competition?
That's an interesting point. There's not in this one, but that's something
Okay.
to hang on to for the next one. Sure. I like that.
It makes it easy. No PowerPoint. Excellent. The PowerPoint 3 zone.
Yes.
Well, didn't even think about that, but you know, we're a club that like builds robots, so you know.
Yeah.
Should we
Good.
bring materials or things like proto boards or
Yeah. If you want to bring stuff, bring stuff.
huh?
If you want to bring some bits, bring some bits. Yep.
Okay.
Like a
And
robot.
We'll yeah. No. We'll have everything we need for the competition, but you're welcome to bring anything extra.
Well, but we should qualify that, Mark, because
True.
we are going to. So Mark will be the judge, and so he can contradict me in any way he wants. So just like expressing our ideas that were concocted over a beer last night.
Yeah. Yeah.
And
A literal napkin and pencil and beer.
yeah. We're not going to allow major components brought in from the outside, such as H bridges, sensors, entire robots that you might use in place of the provided materials. I think that's sort of like the
Yeah.
So I guess the first question I have, you said it was going to move. Is there going to be motors that we should bring, or is it going to be provided?
Nope.
everything that you will be needed to compete at a basic level will be provided.
So I guess what I'm saying is, like, if I bought a piece of foam board, is that okay?
Oh, yeah. Yeah. I mean, yeah, raw materials that you'd use. I mean, the idea is to hack
about
something and have fun.
How about a servo?
What, sorry?
How about a servo?
Judge's
Probably not.
call.
Well, yeah.
So what kinds of things could we bring to help compete at the advanced level?
That's what we're trying.
Popsicle sticks.
I will be providing popsicle sticks. They will be there.
Popsicle sticks, and is that frozen or unfrozen?
Unfortunately, unfrozen.
Oh, man.
I
I
know.
mean, you can't have beer at the makerspace, and now we can't have frozen popsicles either.
If I can keep one frozen by the time it gets from here to there, then I'll get you a frozen one.
Okay.
I did a proof of concept this afternoon, and I think it's going to be fun. I think people will have a good time.
How about LEDs?
Oh, yeah.
I mean, hey, you got to have blinkies, right?
You gotta have blinkies.
Yeah.
Only if you can use an Arduino to blink it.
Ah, you know, do we know?
Right.
And you did mention soldering iron and tools. So if the guys have some soldering iron and some tools,
Yep.
probably help. Depending if there's 4 teams, at least try to get 4 soldering irons and tools around.
Yeah, it'll help out.
Or a proto board, if you're going to use if anybody wants to use a microcontroller, you got to have something to put it in.
Yeah, right.
Oh, you can solder directly to it.
Oh,
But I'm gleaning the microcontroller is entirely unnecessary.
Right.
Sounds like it.
It's unnecessary
What-
at the basic level.
Okay.
But
Need something to blink the LEDs.
it is, the idea is to have like
Well, maybe they're providing a 505 timer.
to stimulate creativity and inventiveness and on the spot hacking, and you may be able to figure out a way to use a microcontroller to do better when the challenge is presented. So it's up to how inventive you can be.
If you want to use a microcontroller, you may want to bring a USB cable and a laptop.
Right.
Right. If teams want to use a microcontroller, someone will need to have a micro USB for the Pico, and maybe have practiced programming a Pico, so they have their Arduino config set up. And but yeah,
Sounds like fun.
Yeah.
I look forward to watching.
So do I.
the time pressure will be pretty extreme. I can say that from experience.
Yes, that will be where the main challenge is. Like we have to start here and we have to stop here, and then that'll be interesting.
Did you say you have the hot melt glue guns and such?
Mm-hmm.
Yeah.
Okay.
I threw a glue gun in my box, and people can bring like stuff that they might want to hack with.
Yeah, we got several glue guns at the space, of course, and I'll bring some baling wire and duct tape just for you, Carl.
Okay. Right.
I think this will be fun. It's something completely different from anything we've done before, and but it's totally in the spirit of what this club is all about.
Yep, that's the goal.
Sounds like fun. I'm jealous I can't be there.
I know.
Sorry you can't be there, Pat. You just need to move down to Dallas, man,
Yep.
and enjoy the 105
Mark-
degree heat down here.
Mark,
Yeah, well, that's I was saying earlier. It's quite hot down there.
A little toasty. So, Mark,
yeah, can I make a suggestion?
maybe.
Why don't you send Pat a list of the materials that you're going to be
Oh.
providing so that he can build along with us?
There you go.
We could do that. We could probably
We
do
could
that.
do that.
Yep.
If you want to do that, send an email out to Tom and myself tomorrow
There you go.
morning.
All right, I'll get onto it.
That way we don't have a huge advantage.
No, sure, we can still have some fun.
Yeah.
Oh, but
Yeah,
if
just
you
have some
know the
parts
list
you
of
want-
materials, that's
what
not
you're supposed
fair.
to do with
No,
it.
just send a list of materials so they can gather the materials.
That's a great idea.
They can learn the challenge at the same time as everybody else, but
Yeah,
give them the chance to build up the material set that you're going to have.
that's a
Okay,
great
well, then
idea.
send that to us tonight, and we can work on setting up materials, and maybe we can work along with you guys.
We'll do
They'll
that.
have the advantage of knowing the list of materials, whereas the locals won't. So we're giving an advantage to the Canadians. That's all right. That's good.
That's
know,
okay.
Leg up.
They're good guys.
Oh,
We
there's
like
They're
them.
good guys.
There's other guys. So there's Chris as well. I don't know if Chris wants to participate, but he's remote.
I don't know. Send me the list of materials. We can. I'd like to know.
Excellent. Okay. The Northerners.
Well, does that mean we need to publish the list of materials being provided, Mark? What do you think?
I think just to those select few.
Okay.
I'd like to keep it separate to the ones attending.
It's,
Yeah.
if it
'Cause
doesn't take
they're
long,
operating under somewhat of a disadvantage anyway. Well, but maybe an advantage in terms of they're in their workshop, they have all their tools at hand and hacking tools. Everyone else will be in the makerspace with only whatever they brought along.
Well, the other disadvantage they have is they're going to be a team of one. As you said, this is a team challenge.
Yeah.
So they're going to be at a disadvantage because they're going to be a
Good
team
point.
of one.
Yes.
Well,
Yeah,
that can
we'll
be an
able to
advantage
split
too, you know.
assignments. Good point.
Can be.
Let's
Okay.
debate.
All right. If you want, Mark, I'll send them the list of materials to to Chris, Pat, and Tom this evening.
Thank you.
That would be good. And then we can, I don't know how much digging I'll look around after the meeting, but at least I can think about, hey, where's this, where's that? And
Yeah,
Exactly.
Yeah, that'll be fun. It'll depend on your Amazon turnaround times, but just so you know, I got 1 day turnaround on parts.
That's what I'm
so
looking
my
at right now.
my Amazon 1 day turnaround is 2 days. and my 2 day turnaround is about 4 days.
And then, this makes Chris an honorary Canadian. I mean, he's far enough north, he might as well be.
It might as well be. Yeah, okay. It's a couple
We will
hours.
take him gladly.
Very cool.
Okay, good. That sounds very interesting. Now I'm even more excited about it.
Are we actually recording at the moment?
Yes, we are.
Oh, okay. All right.
Mhm.
Didn't see the little icons, but good.
So I guess that's it for the Hackerbot challenge. But Paul, did you have something else you wanted to present?
Yeah. So I've been very busy this week. Partly on Lena Robot 2, I pushed updates to Lena Robot 2 for support of the BNO 085 and the IMU and the HC SR04 ultrasonic range sensor and measuring battery voltage on a robot, either via a potential divider or via an INA 219 voltage and current sensor. So some improvements to Lena Robot. I maybe might want to show something I'm quite pleased about. How smooth Moberry teleops nowadays. After installing Doug and Ray's quadrature encoder, it is just a delight to teleop it nowadays. And let me see if I can get that going and see if I can get. So I'm just going to try and show smoothness. Oops. It's not very smooth there. Okay. See if this can work. So the thing to notice is the small, slow, controlled, delicate movements that are possible now. Prior to putting in the quadrature encoders, which now give something like 1400 counts per wheel revolution, it was just super jerky.
So did you print new wheel hubs? Because mine don't look like that.
No,
No?
that's what the mower came with.
Oh, really?
So anyway, that's just to say that I wasn't watching the screen, so I didn't know how much, if that actually showed.
Yeah. Very smooth
Okay.
motion.
So the lesson, the learning for me was that the number of encoder ticks that you get per wheel revolution really matters. And if you don't get enough ticks, then the PID loop that's controlling the robot motion gets kind of jerky because, sometimes it doesn't get ticks and other times it does. And it was sort of like stopping and jerking, starting, sometimes it'd go backwards a little. It was just really kind of difficult to control. So anyway, I'm just delighted with that mod, and appreciate Doug's design files and everything that and work in really figuring out, Doug and Ray's work in figuring out that board, the board to use, the encoder board, and I mean it's just working like a dream.
What was the ticks per revolution before?
Before it was 70 ticks per wheel revolution.
Got it.
And
So at a
that's
slow rate, like I was showing before, you and the control loop was running at 50 hertz. So at a slow rate, you'd be getting less than 1 tick per loop.
Yep. Yeah. That's been my experience with very low rates as well.
Okay. Yeah. So hadn't seen that before, but I'm very, very delighted with it. And related to that, well, I guess not really related to that. I'm just so impressed with the stability of the heading in 6-DoF mode. So just accelerometer and gyro of the BNO 085. I used it to calibrate the left-right wheel distance, because it is just rock solid. So I'd do get the robot to do a 360-degree turn and see how far the odometry said it had turned, then just ratioed that off of 2 pi, and it just came out bang on. So I was like, wow, that BNO 85 is just something else.
Yep.
And then the last thing that I wanted to share from my exploits this week was Fusion Core. Fusion Core is a ROS module that here we go. It's a ROS module that fuses where am I kind of data. So let's see, can you all see this table that I'm sharing, or should I expand it?
Yeah.
Expand it?
Too small. Yeah, there you go.
So it comes with it's a pretty new package in ROS, and very well documented. Oops, I got a bit too carried away there. Very well documented, and as an example, they've got this table that lists different combinations of sensors that help you figure out where you are, that and a corresponding YAML file for configuring the fusing algorithm. So let's see, there's a different picture I want to share first before I go there. Where is it? Getting started. Where is that picture? I know it's here. I know it's here. Okay. Why can't I lay my hands on it? Standard. Sorry for the scrolling. I thought I knew where to find this, but there's a real good done. Okay, that's got to be here. Yeah, here we go. Here we go. This is the, so can you all see this, or do I need to expand it maybe a bit? Okay. So there's a robot running in simulation, obviously, but we'll get to the real world here in a second. It's running SLAM, so it's filling in its map as it goes. But this is their tagline: one estimate from every sensor and every GPS fix earns its place. And what they mean by earns its place means it has to earn its place or it's thrown out. And so they've got reality checks built into the sensor readings. And so the sensors that you can feed into this, it's basically a giant unscented Kalman filter with 23 states apparently, that runs at 100 hertz, and it can accept RTK or non-RTK GNSS fixes, IMU, gyro plus accelerometer, so a 6-DOF IMU such as the BNO85, wheel odometry. If you've got dual GPS antennas, dual RTK GPS antennas, it can accept that as an input. It can take a magnetometer, or even VSLAM. If you don't have like wheel odometry at all, but you've got an IMU and a camera, it can take or camera that is hooked up to something that gives a estimated pose in VSLAM from a VSLAM algorithm. It can take that and it munges them all together. This chi-squared outlier gating means drop sensor readings that are out of what would be a reasonable range. And there's a name for that, which Mahalanobis. What is it?
Mahalanobis.
Thank you. That's the word I was looking for. Mahalanobis. And so that word has an interesting background. Mahalanobis was a guy back in the 18th century when they used to believe in phrenology. You know, that was where they measured people's heads and what bumps they had on their heads and tried to correlate it with whether they were, how good they were, whether they were a good person and whether they were handy with their hands or more of an academic and that kind of stuff. So Mahalanobis was a guy in that era who came up with a way of, given a population of head dimension readings, throw out the outliers. So if I walked into Mahalanobis and said, measure my head and tell me what phrenology says about me, he might find maybe someone whacked me on my head and I have with a hammer and I have a big lump on my head. Well, the Mahalanobis criterion would identify the lump as being an outlier and basically throw it away. There's the rather interesting background to Mahalanobis criteria as a technique for gating unreasonable data points. And I guess chi-squared is something to do with like standard deviation. I really don't know what that means, but it's some measure of what the normal distribution of the data is. It's got IMU, so it'll deal with gyro and accelerometer and odometry bias. So a lot of gyros have a bias, as you guys probably know, and I discovered rather to my dismay on my previous IMU that it continually says the gyro continually has a bit of bias and says it's rotating at like 0.05 radians per second. And so that kind of like throws a twist into the Kalman filters. Well, they've got this thing is geared to deal with that. It's got adaptive measurement noise. So a lot of times with setting up a Kalman filter, and I have to confess, I've never actually set up a Kalman filter, so I'm just going from what I've read here, that you have to, by trial and error, estimate how much noise there is in the process and in the measurements. And you can get some specs on the noise levels from IMU vendors and from the GPS, but you have to tweak it some apparently, and so anyway they've gotten rid of that manual tweaking process in the Kalman filter tuning by making it adaptive to the noise that they see on the measurement. They've got gap-gated coast, and what that means is if you're driving in a car and you drive into a tunnel, your GPS suddenly goes away. So what does that mean? Well, you're now running on IMU plus odometry, so you gradually your estimated position is gradually going to drift, and you may occasionally get an outlier through GPS, but generally you won't. But the point is that it will coast, it will sort of ignore or downplay the GPS, the lost GPS, and use what it has so that it doesn't suffer an outage while you're in the tunnel. And then when you come out of the tunnel, then it picks up GPS and starts using that and brings its estimated position back into line. And then the last
normal
thing is,
EKF should do that if it's tuned properly.
Okay.
As well, yeah.
All right. Yeah. So I may not really completely understand this. I'm just going from what I've been reading on it. So
yeah, no, it's a great. I'm glad you're doing a deep dive on it. I'd like to see actual results of somebody I know running it.
Yeah. Well,
getting it fully up on the external navigation.
Yeah. So, hopefully next week, Kareem.
That'd be great. That's one of the things I've been hoping from Fusion Core, because it seems a lot simpler to get set up. It took me more than a month to get my Kalman filter set up for outdoors.
And then it's got it can handle IMU delay and replay IMU or GPS settings. So GPS settings may be delayed by owing to various factors, and then come in with a timestamp that says, "Oh, I'm way back there." And so what it can do is plug in your IMU or your GPS data back into the history, and then play that forward to give an improved estimated position, accounting for a delayed input. And then ZUPT, zero update. What's this stand for? Zero update position something or other. What it means is when you're stopped, estimated position can drift in a lot of filters, because they don't really know they're stopped. But this Fusion Core can apparently look at your odometry and say, "Hey, odometry says I'm not moving, so I must be stopped." And the fact that the IMU is saying I'm moving a little, and the GPS says I'm shimmering around this way and that, I should ignore that. And
you got to be careful with that, because they could be lying. The wheel odometry can also lie.
if it's like sliding down a hill.
Yep.
Yeah.
Landslides are great at that.
So
Or
actually,
rolling down a hill, like tumbling. I've had
well,
that.
it was rolling down a hill, then you'd still have wheel odometry. It's if it's sliding that you wouldn't.
No. If the whole robot is tumbling
Oh,
down a hill.
tumbling. Yeah. So out of that, you get fused pose plus covariance, and it outputs a TF transform from the ODOM to the base link. And I don't really understand why it doesn't also offer map to base link, but I guess I really don't know. I'm not sure what you mean to do with the map to ODOM transform. But
that is kind of weird, because the whole point of robot localization on my system is to get that map transform connected.
Exactly. But when you have GPS, and if GPS is being used to give you ODOM, then ODOM should be actually fixed in map.
No, ODOM should drift from map. If you look at the RAW standards, it's not the same thing.
It's not required to drift from map. It is allowed to. And in the usual...
It is not supposed to be pinned to map if there are any kinds of discrete jumps.
Correct. And the idea is that the GPS reading, which determines what your position in map is, can jump around, but your ODOM position should be smooth and high frequency. And I think by feeding GPS into ODOM, they effectively lock down ODOM relative to map, and you don't really need GPS for map, because your GPS is feeding your ODOM position.
So it's guaranteeing a smooth transform for ODOM?
It's guaranteeing a smooth transform at 100 Hertz for ODOM, but it's also assuring that ODOM doesn't drift relative to map, because it's anchored in GPS.
That won't work indoors.
Correct. It could work if you had some other absolute positioning system indoors, but yes. So yeah, it has a scary level of let me go somewhere different first. So one thing that I was very impressed by is they've got YAML files for configuring this. I mean, it's a bit of a beast of a Kalman filter. I mean, a 23 variable Kalman filter that can consume this wide a variety of inputs. But they've got configs set up for example, BNO85 custom or ClearPath Husky. Rowcrop is for IMU plus wheel odometry plus RTK GPS. So that's my robot, and I think it's yours too, Kareem.
Yes.
If you don't have RTK, they've got one for IMU plus wheel odometry plus GPS. If you've got LiDAR, they've got one for IMU plus LiDAR, or IMU plus wheel odometry. So they've got all these different YAML configurations, and these YAML configurations, they're not as big as the nav2 configuration, but they're pretty substantial. So as an example, I will bring up the
lower down, there was a nice one that showed an 85 with F9P.
Oh, that's it. Yes, that's what I was looking for. So if you've got a ZF9P, and by the way, just as an aside, I mounted the ZF9P on my robot because they've even got a package as that's part of this collection of packages that has a ZF9P consumer, if you will, that digs more data out of the ZF9P. So it consumes some of those obscure ZF9P packages, ublocks messages that tell you things that give you a better handle on the covariance, so that it can make a better estimate of the amount of noise in the GPS reading. So it's
The
like
standard officially supported package does all that. That's the one I use. I'm pretty sure that's the one that's bundled in here too. Because it'll give you a full covariance matrix, so you know you're drifting, at any point in time what the reliability is.
Correct, but
yeah.
I can't speak with authority to what extra stuff they may be consuming. I know they're consuming HDOP, which the standard package gives you, but the standard driver from that guy in Australia gives you HDOP and a bunch of other stuff. But the question is,
it gives you every single message that the F9P can put out.
But
you just have to configure it that way.
Right. But the question is what consumes it. And the point I'm trying to make that I read,
sure.
Again, not experience here, but what I read is that this package helps them read those messages and feed them into the filter for more accurate estimation of position. So here's the config file for this configuration of the BNO 85 and GPS. And you can configure the publish rate, whether it's got a magnetometer, noise, on encoders and GNSS, max HDOT before it throws it out with the Mahalanobis criteria.
Yeah.
Say for satellites, the minimum level of fix that you want to accept before it says I give up, and where the GPS antenna is, that's a lever arm relative to the robot center. Whether the magnetometer is enabled and various parameters related to that. Thresholds for throwing away outliers, whether it should use adaptive GNSS. So seeing some parameters to feed the unscented Kalman filter. So a lot of parameters that are given here. So it's pretty, I mean, what I'm trying to convey here is it's a pretty impressive package.
Yeah, it looks pretty amazing. I just haven't got the direct experience with it yet.
Yeah.
But a lot of people are starting to turn to it because of the continued dearth of development in the standard packages. And the standard packages are hard to use.
Yes.
The robot localization packages.
Yes, that's what I've read. And I'm sorry you had to suffer through that. I didn't go down that route, and I'm not going to. I'm going to go down this route. And by the way, Kareem, I want to say thank you for some of the directions you pointed me in that I very much appreciate, including Visanti for like controlling your robot and looking at what it's saying on a mobile device and also there's one other important thing you guided me towards.
Pretty sure I put you onto this as well, but yeah, it's all good. It's like I've learned so many things from you too, and others in the various channels. So.
Well, there's another big thing, and I'll think of it in a tick. So anyway, all that to say, this is what Fusion Core is, and the guy does a little bit of advertising in his page. He says he'll offer fixed scope project. He'll take on fixed scope projects for fixed price with guaranteed results. And so, okay, he's in business, but he's contributed.
Cool.
That's reasonable, but he's contributed so much to the community with this package, is what it looks like to me. So
it's really hard to get a sense of how many people are moving to it, though. I wish there was a better way. Seems like the ROS community is sort of broken down, and some of its communications a little bit with what they did with forums and such over this. They had a bit of a break there, and they're trying to rebuild. But they tried to push everybody off to external forum services, and it just did not work.
And ROS 2 has been just a nightmare. I know it. It was Mike actually that said, you really ought to be using what is it? Foxglove, actually. It was Foxglove.
Yeah.
And I finally got burnt out with the traditional ROS tools during this last week, because I was trying to do my B&O 85 testing and configuration. I pull up RQTT and I can't get the damn IMU data because its QoS service level doesn't match. I'm like, oh, the hell with this. But Foxglove just handled it beautifully. So I'm like,
Foxglove has a really nice panel to also look at. Logcat, live Logcat.
Oh,
when you can't get it any other way, and it's like, that's so helpful.
Oh. So I think that's about all I know to say about Fusion Core.
Looking forward to a demo.
Well, thanks, Paul. That's I don't know. I've been disheartened watching you guys struggle with the localization and packages and with the noise and trying to get it to work. And I'm hoping that this, at least the video demo they're showing, it seems to be working well. So it'd be nice to see it set up and doing a demo and working.
You gotta see it in the real world, not on simulations.
Yes.
And
that's
simulations
a complete cheat. Yeah. So that's where we gotta see it working robustly, because there's a reason that this is hard, because it's hard. It's actually hard. The real world is so friggin' noisy.
Yes.
And the situations you'll come up against are so unpredictable, and every possible combination of failure is going to come flying at you. And we're trying to create this really robust, fail resistant or failover capable, automatically resyncing kind of capability, and it's just plain hard. There's not hobby level robotics at this point. This kind of stuff is not.
Yeah, we're hanging with the big boys when we're doing.
We're hoping to, yeah.
Trying to, hanging by our fingernails.
Yeah, exactly. Can't hold on much longer.
Well, that's good, Paul.
Hope we didn't go too deep on the ROS stuff for our non-ROS participants.
I think it was a good overview, and you covered a little bit on the setup, going through the YAML files and stuff. It's if anyone wants to look farther, well, hey, it's under Fusion Core.
I for one appreciate seeing it, and it's making me very grateful that we don't need a microcontroller to complete at the basic level on Saturday. So That's less Ross.
Yes, there'll be no Roz on Saturday.
I'm getting all ready for hot milk glue gun, baby, and tape.
Paul, on your robot
Creative
rolling
side.
around, I've given you a black star, so significant progress.
Thank you.
So yay!
Yay.
Okay, well, that was our list of presenters. We had Paul today. So I don't know if anyone else has something they would like to bring up. Sounds like it's a quiet night.
Crickets. Carl.
I have a non-robot-y thing. If I'm not prepared to just present it, but I just have a question. It's related to mechanical wristwatches and clocks. Has anybody heard of something called a timegrapher?
Nope.
All right.
Not
All
me.
right.
I
You
have
know
a
when you have-
wristwatch that's mechanical, and it graphs the time by going in a circle.
Well, yeah. Well, but I mean, have you noticed, does it go too fast or too slow during the day's time?
Only
Like-
if I exceed the speed of light.
Like how many seconds per day does it gain or lose?
I'm losing a couple seconds a day.
All right.
It's an auto winding watch. I lose a couple seconds every day.
So I've learned from my car restoration thing that because it has a mechanical clock with no joule movement, so I still don't understand the details of how they're made. But I always used to wonder. I remember back decades now. You take these wind up watches to the watch shop, and the guy could make it faster or slower so that it'd tell the right amount of time every day. Whereas if you try to do it, I mean, at home, you'd have to like watch it for a day. Oh, it's fast by so many seconds, and try and turn a little thing like fraction of a whatever, and then wait another day, and oh, I overdid it, and then it's just a pain in the rear. So apparently, there's this thing called, you can Google it, but there's a thing called a timegrapher. Came around in the 20s and 30s, and and these
1020s?
1920s and 1930s. And these things basically listened to the little timing mechanism inside the wristwatch, because there's a couple of standards that they all seem to follow. Like a really common one for wristwatches is apparently 18,800 beats per hour, or 2.5 hertz, or something like that. So anyhow, so they came up with this gadget widget in the 20s and 30s that could listen to the tick-tock of your wristwatch, and then I still haven't figured out how it did it. But it was some kind of like roll of paper and a pen plotter. It would produce a row of dots, and if the row of dots was vertical, you were spot on. You weren't going to gain or lose time in a day. And if the row of dots went one way or the other, then you had problems. It could tell you how many seconds per day you were off. And there's some other measurements it could get just from the audio. Well, that's the 20s and 30s, right? So nowadays, if you go to a real watch shop, apparently, you can get a decent looking time grapher, LCD display and everything for a couple $100 on up. That's how the professionals do it. So if you take your clock in to get tuned. But guess what? I mean, we have these phones, right? So there's an app for that. You can download timegrapher apps on your phone and then put the microphone of your phone on top of your wristwatch, and it'll tell you all this information, like these tube amplifier thing. There's Kareem got a nice search. So anyhow, it's interesting. So I started playing with that last night and feeling much better about my plan to not replace the mechanical movement in my car with the quartz electric one. I'm going to keep the mechanical one, and I'm going to play with timegraphers and see how easy it is to dial it in.
So does that mean if you go over a big bump, you've got to recalibrate or something?
It's a mechanical system, right? I mean, it's just springs and metal. So a big bump. I mean, it's low mass, but a big bump. In my case, I got 70-year-old 70-year-old organic lubricant that's probably hardened up. So for the last 4 years, my one clock, the clock from the dashboard didn't work at all. I could get a couple ticks out of it, then it'd stop, couple ticks. Well, it sat in a box in my truck for the last year, driving around, bouncing around, and it started working last night. So I could wind it up, and it seems to be doing just fine now.
Maybe bumps are, required part of maintenance. I don't know.
And then, some of these apps talk about. I mean, people get a little crazy over this, and it's fun to look in the apps to see how crazy people get because there's the social club. So like you can measure your watch's accuracy every day. You can post the results to the community. Oh, I'm wearing the Rolex today. Oh, I'm wearing the Timex today, and and it'll measure the drift on a day. And it says, okay, so the standard watchmaker apparently, when they do these measurements on the Timegrapher, they'll measure it with the face up, face down, on one edge, on the other. They'll measure it in several different axes because it's a mechanical system and the vibrations, it changes based on how you're holding it. Anyhow, it's fun. That's my total non-robot-y electromechanical diversion of the day without the electrical part.
They're all
Do you know if
based
they're
on
temperature
an
compensated?
effect. Sorry, go ahead.
Do you know if the watches are mechanical watches are temperature compensated?
It sounds like a good research project. I don't know, but I mean, now it makes me wonder because there's clocks, there's watches and clocks without any joules at all. There's ones that have, like, we used to have a one transistor radio, right? So there's watches with 3 joules, and then the high-end watches have 21 joules. Well, what the hell they use these joules for? And I think it's for pivot points, but
The joules are just bearings.
bearings, yeah.
That's all they are. The
But
trick
why
is like it's effectively still a pendulum mechanism, not a normal gravity-based pendulum, but you gotta somehow change the length of the oscillating arm in order to tune it. And so I imagine that's different for different kinds of watch construction, but that's
just
some
changing
pretty
one end of
delicate
the
stuff.
spiral spring, though, isn't it? The one that ticks off the seconds.
Well, there's got to be several different.
There's usually a
common mechanisms.
hairspring or balance spring in there, but it's not the spring that you change. The spring is just providing the reflexive action. So you've got to change the arm length, just like in any pendulum system. And that's probably the thing that, how they do that, I don't remember. I studied this a long time ago, but
either stretch or shrink the pivot point. So either the spring travels. Well, okay, this I guess you would say the spring pushes that.
There's still a mass
so
that
far,
has to,
yeah.
Maybe not much of a mass, but some kind of mass somewhere.
Mm.
And then there's got to be some other kind of different constructions as well, because like most wristwatches and the dashboard clock for my car, they have the standard 18,800 beats per hour rate. So tick tock, tick tock, tick tock, tick tock, 18,800 times per hour. But there's apparently 3 or 4 different things, 25,000 all the way up to 28,000 per hour. So there's a couple different standards that these use. And anyhow, for total distraction of totally irrelevant to robot-y things and anything else I'm doing, it's kind of fun to dig into it and figure out that there's an app for that.
But hot glue won't help you.
No, not one bit. No.
Well, thanks, Carl.
Maybe you want to dig out
interesting
all my
diversion.
wind-up wristwatches, so I'm running around measuring them now. And
going back to Saturday, is there a size limit or a weight limit?
There'll be a max limit, I'm sure. Yes.
Well, you're kind of constrained by needing to use provided materials plus, whatever other hacking things you might
So
want.
clearly you're providing at least 2 motors. You can give us that much.
Yeah,
right?
yeah.
Or just a solenoid, bump, bump, bump. I mean, a bouncer. I mean, a buzzer.
Ooh.
They got all kinds of things that they do, right?
Vibration, yeah.
We need to talk to Carl then next time, Paul. Next time we plan it, get some ideas off of Carl.
Yeah.
Good ideas. Reading an old book. I was just thinking of those crazy little things they do for elementary school kids where
Oh, the
Where you
bristol
just
brush,
have-
the vibrator.
yeah, they just sit on a broom and it shakes and it like it just yeah.
Bristol bots or the solar robotics, beam
Something like
robotics.
that. Yeah.
Well, thanks, Carl.
Sure.
Anyone else have something robot related to discuss? Well, I think that's it. Are we
Yeah.
done for the night?
Okay.
Get to go home early.
Sounds like.
Get to go home. Got homework, study for the weekend for Saturday. Make sure you're all set up in your duct tape, cardboard, and baling wire stuff.
Look at Chris. He's ready to go. He's excited. He's going to dominate this, whatever it is.
Yeah, remember, remind me who won the simulation line following race. Remind me.
Send me your email, Chris.
At least I had a physical thing to back it up at some point. But
This is how
Did
fast
everybody
can
get
you
Mark's
hack-
email?
What?
Did everybody grab Mark's email out of the chat before we disconnect?
Mark's email?
It's just president@dprg.org.
Okay.
Yeah. But just send me your email if I don't have it already, and I'll email you what we're kind of planning.
Oh,
Okay.
I just sent the parts to Pat, parts list to Pat, Tom, and Chris.
Oh, beat me to
Okay.
it. All right.
Yeah.
Well, never mind. Never mind.
So,
I've got it, so I'll take a look after the meeting and see what I can put together for Saturday morning.
All right. Cool.
Well, there's no sense being just forced to watch.
Be cognizant that you've got a little bit more of an edge on everyone else, because at least
Yeah.
you know the parts that are being provided. You don't know the
Yeah.
challenge,
But don't start building it yet, because we might not be following the rules.
right?
I will just gather whatever materials I can off
There
the
you go.
list so that I'm ready to go at
we tried to make it like so. Some degree of inventiveness would be required.
looking forward to it.
Cool. Me too.
All right. See some of you on Saturday.
Yep.
sounds good.
Indeed.
Hey, guys.
Bye.
Have a good
Hey
week.
guys.
Night.
Bye.